Now you'll learn about the one-way messaging pattern, also known as datagram. With one-way, the client does not expect a response back from the server. It just makes the request and then goes about its business doing whatever it wants. This is different from the request-response pattern because with request-response, the client expects a value to come back to it. If it's a synchronous request, the client would block. If it's an async request, the client would still process the value on a callback. Now here's what the client does when it makes a one-way request. First, it blocks until the message arrives at the service, and this is key because if you have a large message, then the client is blocked as long as that message is transmitting across the wire. Now, once the service receives the whole message, then the client unblocks. So the service will continue processing that message, however the client will not be blocked. That's where the client goes and does the other processing that it needs to do. So now I'm going to show you how one-way works. Here we have a solution with a few projects, and I want to demonstrate how one-way works. I'm going to do this by creating a service that runs for a while so that the client can call it and unblock right away and then see the service keep on running. So let's look at the service first. On this contract, it has an operation set temperature with the operation contract, and it has its is one-way parameter set to true. That makes it one-way. Now notice that the return value on that set temperature is set to void, so that's appropriate. In the implementation of this service, I have a for loop that iterates every second and just prints out the results to the console so that you can see what's happening with it. What I've done with this service is created a service host so that I can have a console up and we can see what's happening. Over in the client, all I do is instantiate the proxy, call the set temperature method, and then wait. But on both sides of the set temperature method, I have a calling and I have a call. So this is going to tell us what's going on in the meantime when this service is called. What I've done here is, since I have a service host, I've made sure that the host is started with multiple startup projects and then the client. And I'm running this project as administrator. So let me run that. And here's the client and the host. There's a host running. The client returns, but the service keeps on running. So there you have it, one way. The client made the call. As soon as the service got the message, it started running, but it returned to the client, and the client was able to do whatever it wanted while the service was still processing the message. And that's one way. Another messaging pattern is through callbacks, also known as duplex. With callbacks, the service can call back to the client. What this does is it enables two-way communication where the client calls the service and then the service can call back. And we can do this either via the service calling back the client during the same request, or we can hold a group of callbacks and then call back a bunch of services at the same time, or call back that service later when something happens. Here's how you would set up the callback contract. First, the service will establish the callback contract. Essentially, it creates an interface and says, when I call you back, I'm going to use this interface So that really means that the client has to implement that interface, and it will implement the interface, and when it calls a service it will configure its proxy so that it lets the service know what it can call back to. Now, once the client makes that call to the service, then the service can get a reference to the callback and be able to call it back right away or later. I'm going to show you a very simple scenario where the service calls back during the same service call, but I'm also going to show you a very simple publish subscribe type scenario where multiple clients can subscribe to the service and the service can notify them whenever some type of event calls. So let's go see how that works. Here we have a solution with a couple projects, and I'm going to show you how to implement the callback messaging pattern or duplex. Let's start with the service contract. The service contract is decorated with the service contract attribute, but notice that we have the callback contract parameter set. It's set to the type of the callback contract, which is iWeatherService callback. Notice the convention I'm using here, where I'm using the service contract name appended with callback. You don't have to do this, but it helps keep in your mind the association that this callback goes with that service contract. We have a couple operations here. One is update temperature and another one is subscribe. Next, let's go look at the service callback contract. Notice that this contract operation is decorated as one way is true. Also notice that it has a void return value, meaning that it does not return a value, which is appropriate for one way. So we have a one-way callback, and by the way, these one-way callbacks are convenient because you don't want the service sitting there blocking on one or more callbacks that could cause it to time out to the original caller. So this is really a best practice. Now the implementation of this is the update temperature right here. And this is how we get a reference to the callback object that the client sent us. The operation context current gets the current operation context. We call get callback channel, passing in the type of the callback contract. So we get a callback that's this callback contract type, and then we can call the callback contract methods, passing in the value that we need. The rest of this method I'll discuss later when we talk about the publish subscribe patterns, but really this is all we need for the current service implementation. So now let's go look at the config file. And in the config file I'm using a NetTCP binding. I could have used WS dual HTTP, but it's more complex and it doesn't support like Azure Relay binding really well. So this is really the way to go as far as performance goes. I also have a base address that's using the NetTCP binding. So that's configuring the service for this duplex contract here. Now let's go to the client. Over on the client, I'm calling this, or I'm instantiating this weather service client. Now let me show you a little bit more about that before I go on. Over on the service reference, I'm going to expand this and we'll go look at the internals of this proxy. And if we go down here, we can see this weather service client right there, and instead of deriving from a client base, it's deriving from a duplex client base, and that's because of the way we have the service contract that implements the callback to the callback contract, and we have the callback contract set to use one way. And notice that the constructor overloads take an instance of instance context. So that's the proxy. Let's go back to the client implementation. So here's that proxy, and it's taking an instance of instance context. And instance context refers to the callback object. So this is how we associate a callback through an instance context to the service via the proxy. Now this weather service callback is implemented here. Remember, the client has to implement the callback contract, and that callback contract was implemented in the proxy. See, weather service callback? So we got that when we right-clicked and said create this reference with the service. So now we have a proxy set up. All we have to do is call the service. And that's what I do here. I've blocked it off with a couple right-line statements so that you can see kind of like the interaction of what's going on there between when I called the service, when the callback occurred, and so on, because the callback will also print out that it was notified too. Now, we have everything in place. Let's go ahead and run this. So this is the client calling the service, and the service gets a reference to the callback that was sent via the proxy constructor. And there you see the client is printing out what the service sent it back via the callback, and then it's over with. Okay, so that's the first thing I wanted to show you. That's the mechanics of setting up a callback messaging pattern. However, there's another pattern that you might want to implement, which is kind of like a publish subscribe type pattern. And so let's go back to the service itself to discuss this more. So there's the update temperature. Notice that I've put a static list in here of the callback contract type. So I'm going to maintain a list of contracts. Now down here in the subscribe, I'm getting a reference to the callback that the caller sent and adding it to that list. So essentially, any clients who call subscribe, it could be one or a dozen, I'm going to grab a reference to their callback object and hold it in this list. So that's the subscribe part, but the publish part is really the update temperature. I'm not calling the method publish, I'm calling it what it is. But notice that it goes through and gets the callback. And here it's calling back to the original caller of that, but it's also iterating through that list. And it's calling the callback on each one of the items in the list, whoever subscribed. Now, let's go to the client. And last time that we ran this, you might notice that we only got one call to the callback. This time, I'm going to use that proxy to call subscribe and build this real quick. Now when I run this, the client will call the service, and then the service calls back twice. It called back once because in the update temperature there was a normal callback to the caller, but it called back the second time because the client had subscribed and added its callback to the list. So when the service iterated through the list, it called the client back a second time. So that's why we have two here. So that's how you implement callback messaging patterns and publish subscribe type patterns. There's another messaging pattern that can be implemented via WebSockets, which I'll call push. Essentially, WebSockets let you push notifications from the server to the client. You can use this for duplex communications. To do so, you would set the binding to net HTTP binding. Then you configure that binding to use WebSockets. And then you would set up your duplex callback code as normal. And that's what we're going to do in the next demo. Here we have a solution with a couple projects, and I'm going to show you how to configure a WCF service to use WebSockets. So, we'll go to the service first, and notice that it's set up with a callback contract of iWeatherService contract. And here's the callback contract with on temperature updated, set to temperature, and the operation contract is decorated as a one-way. And then the implementation is that I get a callback and then call back to the client via the callback contract. So if this all looks like the normal way to set up a duplex channel, then you would be correct. Now here's what's different. If I go to app.config, notice the configuration here. I'm using a net TCP binding. But in that net TCP binding, I also have a special configuration for it. And if I go up here to the net TCP binding, you'll notice that I set this WebSocket setting to transport usage as always. Let me show you a couple of the other options. There's when duplex and never. So you can set it to never and just use net TCP over HTTP. Or you can set it to whenever duplex. And that means that you have a callback contract. However, I always want to use it now, so I'm going to set it to that. So that's it. I set up my service as a duplex service, and I used my net HTTP binding with WebSocket setting set to always. Now over on the client, it's implemented with a proxy that takes a callback via instance context right there, and here's the implementation of the callback that prints out a write line there. So this is all normal for a callback contract or duplex, and then I just call. Now when I created the service reference, what happened was it went in and created a proxy based upon the configuration of the service, as it always does. And let me show you what it generated. So here's the endpoint address, and notice that it's using the WebSockets protocol, WS. And also notice that it doesn't have a port here because it's using port 80. So WebSockets can use port 80 or 443. Same here. That's where it was set up on the server. And here's how it's set up on the client. And it also has a binding configuration. And the binding configuration is set to WebSocket setting, transport usage, always. So now the duplex communication is going to happen over WebSockets. So let me run this. There's a client calling, and the service called back, and the client is over with. And so that's how you use WebSockets with WCF.